Hello and welcome to another tutorial of SystemVerilog in 5 minutes. Today we'll be talking about class randomization. This is a simple example of deriving a byte value. This mechanism is directed and quite methodical. If you don't want this, you can use random value. The system function $random will give the variable a random value. If you call the function multiple times, this could be the possible values for the byte. There is also a uRandomRange function which allows you to specify range. This is the max value and this is the mean value, and this could be the possible randomized values. Apart from these two, there are also other system functions such as dist normal and dist Poisson and so on. Now let's move on to class. If you have a class handle, you can use the random system function on the class member like this. The bit B will get some random values such as this. The problem with this is if you have more variables, all of them have to call the system function individually. Actually, class is a built-in randomization feature. You can mark a member variable with the keyword rand. Then, if you call the built-in function randomize, the class will collectively assign random value to all the members marked as rand. This would be the possible randomized values. You can also mark a member with randc, which means the randomization will not repeat the value until all values are used. If we look at the bit, say the first value is 1, so the next value would be 0. By now all values are used once, so a brand new round of randomization will begin. The value is 0 here, so the next value is 1. Class also allows you to add constraint. This is how you create a constraint. Inside the constraint is the rule for the random variables. For example, we can limit the byte to be larger than 0, and smaller than 3, and equal to 1, and not equal to 2. Note that if you have smaller than and larger than rule, it cannot be written in this manner. It can only be written in this manner. Now the constraint solver will combine all of these rules. In this case, the byte will always be 1. Say if you specify byte is not equal to 1, this would be a conflicting constraint to this one. As a result, the constraint solver will fail the simulation. Here are some other ways to specify constraint. This is a list of discrete values to choose from. This is a range of values. For these two constraints, every value has equal chance. To control the probability of the values, you can use the dist constraint like this. This means that the value 0 has a weight of 4, and the values 1, 2, and 3 each has a weight of 2. This is another way of specifying distribution. In this case, 0 has a weight of 4, and 1, 2, and 3 all share a weight of 2. If you call the randomize function several times, this would be the possible randomized values. Note that these two constraints, they don't have functional conflict, they only have probability conflict, so they wouldn't fail the constraint solver. Imagine that if there is another constraint to set the byte to 1, it will cancel out the distribution constraint as the value 1 has 100% chance. This is an if-else constraint. If the bit is 0, then the byte will be 0. Else the byte can be 1, 2, or 3. These are the possible randomized values. If you pay attention, you realize that there are a lot of zeros. The bit has 50% chance of becoming 0, and when that happens, byte will become 0 too. So it's difficult for the byte to be 1, 2, or 3. You can use the solve before mechanism to change this behavior. In this case, it will try to randomize the byte first. 0, 1, 2, and 3 has 25% chance each to be selected. The bit value is chosen after that. As such, solve before mechanism can change the probability of the values. This is a class with a multiple constraint, CST0 and CST1. Similarly, the constraint solver will combine all rules. If you call randomize, this would be the possible values. Actually, you can stop a rand variable from being randomized. You do so by calling the rand mode function of the rand variable. This code here turns off randomization for the bit. If you call randomize now, the bit will no longer be randomized, it retains its old value. Similarly, a constraint can be turned off as well. The example here turned off CST1. If you run randomize again, the byte can be larger than 3. If we look into the randomize function, it does 3 things. Pre-randomize, randomize the rand variables, and finally post-randomize. Pre and post-randomize by default do nothing, but you can override them in the class. One example is to use them to print the values of the variables. Another example is to use it to override the values. For example, the randomize function cannot randomize the value to be x. You can use the post-randomize to achieve the purpose. You can use a switch to be used in the function. It is by default 0, but if the switch is set to 1, it would change the byte value to be x. If you call randomize here, this would be the possible value. After you set the switch to 1 and call randomize again, the byte will be x. We've learned about class randomization today. Next, we'll talk about class inheritance.